Oh, there we go. Welcome, everybody, to the combined Denver Java and Boulder Java users group. We're going to try something new tonight, so let us know if you like it or if you don't. We're going to do an abbreviated format for the introductions, so I don't take up as much time. So one of the things we always talk about that we do want to mention again is to email us for topics for our talks. If you have something you want to give as a presentation or you want to see discussed, email us or reach out via the Meetup site so that we can put on a talk based on that topic. So the other thing is we're going to share a survey to see if you're interested in meeting online again, continuing to meet online, or if you want to meet in person once we can meet in person again. We're working with Pivotal. We don't know if they're ready to do that yet, but when they are, if you want to meet in person instead of online, you got to let us know and we'll see what we can do. I just have one quick thank you. We're still giving away stuff from IntelliJ, so I want to thank them for that. Agile Learner is also sponsoring some giveaways that the Boulder Java Users Group gives away. We want to thank them for that. Mike will handle those drawings. And I also want to thank Chris Woina, who's on screen with me as well, for running the Boulder Java Users Group. And thank Mike and Zeddy and Matt for doing all they do for the Denver Java Users Group. Tonight's speaker is Pejman Ghorbanzade. He's going to talk about improved productivity through continuous regression testing. And I'm really excited about this topic because we need to be better about our continuous testing, regression testing at work as well. So without further ado, let's hand it off to Pejman. Thank you so much for doing this, Pejman.
Thank you. Hi, everyone. Happy to be here. Thanks so much for taking the time. I hope that you would find this presentation useful and worthwhile of your time. I'm assuming that you see my screen. The title of this talk is Improving Developer Productivity Through Continuous Regression Testing. But fun fact, the Meetup title has a 60-character limit, so you had to reduce that to improved productivity. But the word that we omitted is actually important, developer, because I'm a software engineer myself, and I think that the notion of developer productivity is actually like key for like building better software faster. Now, this is going to be an interactive kind of discussion. So I'll try. So please feel free to add comments in the chat. I'm going to keep a look, keep an eye on the chat, and I'm not going to just go through a bunch of slides. I only have 20, so I'm going to blitz through them. If you feel like I'm going too fast, please let me know. I'll be happy to slow down. And if you think that like this is too boring, you want to skip to the fun part of the doing the actual hands-on live coding, then again let me know. And if you have any questions, please feel free to send write in the chat. I love to take the questions as they come, so that would work for me. So I'm assuming that you see my screen. There seems to be like a glitch in the screen. I don't think it's my machine because Billy Corando had the same, but I'll try to find that. So here, the agenda for today's talk is I'm going to give a very brief kind of intro about software testing in general, and then talk about the motivation behind this talk, and then the snapshot testing, and then finally I'm going to introduce regression testing. The hands-on demos that I've prepared are both covering snapshot testing libraries as well as regression testing solutions. So a little bit about me. I basically was born and raised in Iran. We moved to Boston. I went to school there and then got a job at VMware Carbon Black, which is a cybersecurity company. I worked there for a year and then moved to Minnesota. I'm based here. We've been living here for 6 years, and I've been working for Canon Medical Informatics for 4 years. Until last year when I left my job to start a startup about continuous regression testing. So I'll get back to that in a minute, but let's start with software engineering in general. I want to basically segue to software testing by way of basically drawing contrast between programming, as is the practice of writing code, and software engineering, which is solving a business problem through code. And I think it's important because when we talk about regression testing and all these testing methods, we're actually talking about building software for real world and building software to last. So the difference that I see between the two is that in software engineering, you are actually trying to solve a business problem in the real world. The picture you see on the right is actually the Indiana Bell building in 1930. And this was actually built way back, but then they wanted to move a highway in the city that crossed this building. So they either had to kind of destroy the building in general, or just to change their plans in terms of building the highway. What they decided to do is to actually kind of rotate the building to make way for the highway. And the reason behind that was this was a telephone switching building. It was important for it to be operational all the time. And I think the reason I put it here is because, again, it shows the difference between just the practice of building some building, and kind of going a little slightly higher level and thinking about the kind of implications of our practices, the engineerings. I'm sorry in the chat to hear that the screen is frozen. I don't know what exactly is the root cause. So yeah, thank you for refreshing the screen. Yeah, so this building has a very kind of interesting history that I highly recommend for you to check them out. Again, the name is Indiana Bell. Oh no, Sophia, I have the same problem every time that I'm switching the screen, this slide. But this building is actually yet another building. The reason I put it here is to kind of show that when we are talking about building software in real world, it's all about different components on top of each other. For us to make sure that these components could stick together and kind of solve a business need, they need to be put in a kind of strong foundation. And for us to get to that foundation, there needs to be practices for us to check, whether the efforts that we've put through, the software are so far basically correct and just. Now, the interesting part about checking whether you have the right foundations is all these testing practices that we do. If I'm pretty sure that you are familiar with software testing pyramid, which is basically advocating for us to have more of our tests in the lower level kind of the pyramid, where we have faster feedback cycles and are basically can write code that are cheaper to run. The properties of a good test, in my opinion, are tests that are cheap to write and then easy to read, fast to run, and also easy to change. Now, of course, this software testing pyramid is pretty old by now, but things have changed. Our technologies have improved, and we now have remote computing resources that could run some of the tests that we felt are kind of higher cost in a much faster way. So in my opinion, when we think about software testing, with the traditional way of, hey, let's just write lots of unit tests because running end-to-end tests are taking longer. That still applies, but the cost that we associate with those higher level tests are like basically much less now. Now, the reason why we want that kind of pyramid to have like a wider foundation is because all of these kind of tests that we write are supposed to give us feedback about the the quality of our of the code that we are proposing to our software. When we traditionally look at software testing or software development lifecycle, we think of, well, you write code first, and then you kind of test it. If it works, then let's deploy it, and then do lots of observability. And if then we have good use cases, or feedback from users, and we are going to iterate through this process. Well, that applies to like basically the running a good business. But from the software engineer perspective, there is a certain kind of life cycle in play here. And the way that I think we could kind of think of it is to have these two life cycles as two loops. The inner loop is the the experience of the software engineer, which is kind of whose daily work involves writing the code, running the test, and then doing code reviews, building code, and all that. And then there's this kind of other higher level life cycle of, hey, let's just basically release this particular version of our code for our users to use. If there is a disconnect between the two, or if like there is a long feedback cycle between the time that software engineers are writing the code and the time that they understand that, hey, at least I didn't break anything, or I can now go ahead and kind of push this, or like basically submit a pull request for my teammate to review, then there is this constant waiting mode that removes the basically that introduces a context switching cost, essentially, that removes the productivity. And I think for us to remain productive, we need to have very fast feedback cycles from the time that we are writing the code and from the time that we are testing it. Basically, we are making sure that it's working correctly. Now, the reason is, of course, the longer it takes for us to, get to that feedback cycle, then the costlier it would be to find and fix our bugs. From the software developer perspective, if I have to wait for a particular version of my code to get released out there to find out whether I did my job right or not, then of course, not only it takes time, but I'm also going to lose the context of what I've been doing. Because time is passing, then I might be, switching my context to something else. And now when a bug, appears, then it takes lots of time for me to get in the zone of, hey, let's see what I've been doing. So therefore, if I can find those, side effects of my code changes as early as possible, hopefully during the development, before I even submit a pull request or, kind of ask some QA test engineer to review it, I'll be able to, be more of in that productivity zone. But the unfortunate news for our industry is that even today in our world, it still takes a long time for us to get to that feedback. On average, it takes 23 days for software engineers to get confidence that, hey, I didn't break anything and my code change works as I expected to. And 23 days is a long time for a software engineer. It's certainly much our expectations of this time are usually less, but what happens in our practices in real world is that I make a code change, I run my unit test. Hopefully during the CI pipeline, I run even more tests. And when it gets to the time for me to say, all right, now I can go kind of do something else. I'm going to move my tickets to the in verification column for the QA test team to go do their own testing. And that's the problem, I guess, because when the QA testing team are going to find some issue there, then of course, like it's a separate team until you get basically the time to go back and kind of address the issue that they filed. 23 days might have passed. But in general, the purpose of this talk is to kind of propose solutions and testing practices that could help us reduce this time and the feedback cycle that we usually deal with. As much as we could reduce this time, if we are basically saving in productivity, and essentially our business is saving in terms of cost of development. So let me now tell you a very kind of short story about how it is that I was interested in continuous regression testing. At Canon, we had this kind of project that was part of. We wanted to replace an old kind of component that was in the lower level critical, components of our system. And this component was written many years ago. It was 500,000 lines of code. The people who originally wrote it were no longer in the company. So for us, it was all, hey, let's maintain it for as long as possible because we don't have the time to fix it. Until it was clear to our management that the time that we are taking to actually even understand how this kind of legacy code works is so long that the cost that we are paying for just maintaining the system might not be justified anymore. That it might be actually worth it for us to replace this with a whole new system that we know how it works, and it's probably better documented and better tested. So the problem that I like you to think of is how do you with all the tools and technologies that we know, ensure that we could rewrite or replace this kind of legacy system, which is very large in size. Of course, from the business standpoint, it would be to our benefit to make sure that as we are making code changes, we can still make sure that those code changes are safe. We don't want us to wait for however long it takes for us to complete this project to then go and test it. We want to make sure that as we are making code changes, we are getting closer to the behavior of the legacy system that we are trying to replace. So the first, when we started this project of replacing this legacy code, the first solution that we started with was to create a kind of a test solution that would essentially run the legacy system once with whatever number of inputs that we have as test cases, and then run this new system that we are writing, in parallel or after that, but in the same process, so that whenever we get the objects or the output of these two workflows, we could compare the two objects in memory and kind of reveal whether there are differences or not, or kind of create a report of here are the differences that we've justified so far, here are the differences that we still need to tackle. This system actually worked, but at the same time, it was very clunky because we had to maintain in this test environment the dependencies for both of these systems. And the legacy system never changed in behavior or performance. So every time we were running that old workflow, we were basically wasting time because the output that the workflow had to generate for every test case was consistent from one version to another. And that essentially that lost time means that we got very kind of long feedback cycles. We had to wait for about a day to test our medical software with 16,000 CT scan and MRI data sets. And that kind of one day might be, fine if you want to just basically, do some code changes here and there, but we were trying to replace that system by writing code. So it was important for us to get to the feedback of, hey, at least so far, the changes that we are making are fine. We can, go ahead, make further refactors. The second system, or the solution that we kind of tried to devise, because that old system was, was time-consuming to run, was essentially to run the old system once, and whenever we get the output of that old system, we would store that output in some place. For us, it was basically in a file for every given test case. And by storing that in some snapshot file, we would then be able to just use those snapshot files every time that we are running the test for the new system. The new system would produce another set of those snapshot files, so we compare the two and find the differences. This kind of method is in software industry sort of known as snapshot testing, because you are essentially generating snapshots which are like describing the behavior or potentially performance of your code in a snapshot of time, in a point of time. And then it's very well known. It's not specific to Java or any other language. In JavaScript, the snapshot testing is kind of associated with a popular testing library, Jest. But every language has its own kind of set of tools for snapshot testing. The problem, the usual problem with the snapshot testing is that the time that it takes for you to generate these snapshot test files might be, short, but at the same time, the time that you need to spend inspecting any potential differences might be very long, depending on how many files you have. Because these snapshot files are essentially storing the output of your workflow, that every time that you're generating, making a code change that may kind of change the output, then essentially you end up with a different set of files. So inspecting all these files, comparing all these files together and inspecting the results is very mechanical and very boring. So in general, this might work for very small projects, but at the scale that we were trying to work, this was very difficult. So I'm going to stop here because I don't want this to turn into a boring kind of slide presentation. I'm going to now kind of give you a demo of a few snapshot testing libraries. And I have prepared a few. So the old kind of a snapshot testing library in Java ecosystem is called JSnap. This is no longer maintained very well, but at the same time, if you look at the number of downloads on Maven, it's still significant. So it's interesting, weird. Perhaps a more modern snapshot testing library, which has a kind of easier to work with API, is called Json Snapshot. So it's this repo that I'm showing here. The API for this is very simple. The idea is you integrate this library with your kind of the JUnit framework that in Java you might be using. There are also like certain plugins for different test frameworks. But in general, just like using the same kind of framework that you use for running the unit test, you could write code that would essentially just call your code under test. And whenever you get the output, instead of asserting the actual value against an expected value, you would start kind of storing the results in a file, and check, and the snapshot testing library in the runtime would try to look for those files and then compare the actual value against the value that is stored in every file. Of course, this means that those files have to live somewhere, especially if you are talking about the snapshots that were generated in a previous version of code. Then the kind of the usual practice in almost every language is to check in these snapshot files inside your version control, so that they're still available when you are running a new version of your code. Now, that's in my opinion a little problematic, because version control is designed to store the source code of your code, not the output of certain test workflows. So this model isn't quite developer friendly, because now every time you are making code changes and you end up with a new set of kind of snapshot files, then you need to add a new commit, update all those snapshot files in your version control. It's very noisy to maintain all these snapshot files. But again, that's not a critic of this library that I was showing you. It's a critic of the general snapshot testing framework. And the more kind of popular version that I'm not going to do a deep dive is called Java Snapshot Testing. This one is basically having the integration with JUnit platform as well as Spark. And the idea is kind of the same as the JSON snapshot that I showed you. You basically annotate the function in your JUnit kind of test directory with the snapshot name, and then the test library would essentially create files with the same name somewhere in your in the test directory, and then compare, kind of look for a snapshot files that exist in some directory in your version control. I'm not going to do a deep dive on any of these, because the most popular snapshot test library in Java is approval test. At least as far as I've done my research, this seems to have the most traction at the moment. And I'm going to actually give a live demo of this library. To make this more interesting and not just have to show you the API, I'm going to use a refactoring kata. So if you're familiar with pair programming and mob programming, usually certain engineering teams use code katas to practice kind of working together, practice maybe refactoring the skills or testing the skills. There are plenty of refactoring katas on the on GitHub. The one that I've chosen today is kind of called supermarket receipt. The idea is that it tries to basically imitate the workflow of checking out of products in kind of a supermarket. So you go, add a bunch of products to your cart, and then you check out. The system that we are trying to build here in this example is the receipt kind of or checkout system that provides a receipt as the output of your kind of code under test. So you see here some example code. This is a very simple kind of JUnit test. Here I'm creating a product called toothbrush. This product has a certain price. Then I add another product, apples. I perhaps can specify the amount, the unit of this product in kilo instead of unit. But then the idea is once I have these products, I would add these kind of products that I've added to my cart to that teller, and then create this kind of shopping cart. The idea is at the end of the day, you end up with this receipt, and this receipt is basically a representative of every item that you are purchasing. So if this is the output kind of object of our code under test, then we could certainly start checking if that output matches our expectations by writing assertions. In this case, these are very simple assertions. I expect that you all know the basics of unit testing, so I don't want to bore you here. But if I was to like basically add or test this code under test with one or two test cases or use cases, then of course writing a unit test would make total sense. I would be able to say, all right, I am passing this particular input. In this case, it might be certain products that I'm adding to the cart to basically replicate a real world scenario, and then I'm expecting certain things in the behavior of my my code under test. The problem arises when we want to basically test our code under test with more than just a few test cases and use cases. What in most cases, we kind of resort to adding more and more unit tests for any one of those test cases. If you want to test, a use case where we might be checking out an empty cart without adding any product to it, then we would write another unit test, call it, empty cart. That's not a problem by itself, but in lots of kind of real world examples, the type of software that we interact with day to day or we build, the kind of surface area for our software is usually more than just checking out a cart. The test cases and the kind of inputs that we need to test are just more than what we could afford writing unit tests for. So in those cases, using a kind of a snapshot testing library might make more sense than just defaulting to snapshot testing all the time. There is no one size fits all in software engineering anyway. So in this case, let's just say we want to like make very kind of minimal modifications to this unit test to enable using a snapshot a snapshot testing instead of unit testing. The idea of an approval test is that you don't change the kind of the unit test itself in terms of like adding an annotation or specifying the kind of the name for your snapshot test file. The idea is once you run your workflow under test and you end up with whatever it is that you call the output of your workflow, then instead of adding these assertions, you can essentially use the approval testing framework and replace all of them with approvals, verify. And in this verify, you can basically add anything that you feel is representative of the behavior of your workflow. So in this case, I have a receipt, but because I want to kind of print this receipt and kind of store it in a file, then I need somehow to create a textual representation of this object, the receipt object. So here I have basically this repository that I'm using is already creating a receipt printer that I can use to kind of get to that functionality of stringifying my receipt object. In this case, I'm kind of creating a receipt printer. Let's call it printer, and then I'm going to create this printer. And then in the printer, I'm going to use the print receipt and then pass my receipt to it. The output of this function is a string, so I could just simply use that string as the input to my verify function. And that's it. So in this case, we are replacing all of those assertions with this simple one-line approvals.verify. That's great as long as everything that we were asserting for, everything that we were checking previously is kind of having a corresponding element in the output that this receipt printer is generating. if I was, testing the number of like the units for a given product, and there is no sign of that in that kind of a string that I am storing in the file, then of course this is not a great replacement. The idea is it's up to the developer to create a kind of comprehensive textual representation of their code under, or the output of their code under test. So if I was to run this test, I would run it just like I run all my unit tests. If I have maybe other files and other unit tests inside the same for the same kind of workflow, then that's fine. I'm essentially here. I'm only just running Gradle itself and running the unit test. Now, the command that I ran was Gradle test, but as you see, it failed. And the failure here is described as the 10% discount function failed, which is this unit test, or this function. And if we look at the output, the error message, it says failed approval. And here it says that the approved file, 10% discount dot approved is not available, but then we have this received. The reason is the snapshot testing library approval test is basically creating this a snapshot, but then it doesn't know, if it's correct or not. It's just some output of our workflow. To test if it's correct or not, it relies on finding a snapshot of a previous version. Well, this is the first time that we are running this test, so there is no, a snapshot test file anywhere in our, kind of repository. So therefore, it's kind of failing because it's failing to find the correct behavior or the behavior that we trust as baseline. The idea is always with snapshot testing is the first time that you run them, they fail. It's up to you to check the output of your kind of workflow under test and see if they matched your expectation. In this case, I see that this snapshot testing library has created a file called 10% discount.received, and this received file has the content, the textual representation that I was referring to. So in this case, as a developer, writing this snapshot test, I could take a look at this output, see if it matches my expectation. And if so, then I can basically say, all right, I trust this now to be the new baseline, the baseline of my code under test. From now on, if I'm going to make changes to this workflow, then I want the snapshot testing library to compare the actual value against this file, whatever is in this file. So all I did was to kind of rename this file to approved. Now, if I run this again, notice that I didn't change anything. I'm just running this, my kind of JUnit again. And I see that this time that it is passing because when the snapshot testing library is generating the new file, it compares the two and finds that they are identical. If there are any differences, then of course it's up to the developer again to compare the two files in their favorite kind of diffing program and see if the differences that are there are matching their expectations. This I'm trying to be careful not to advocate for this practice because I'm well aware that this is kind of clunky in terms of everyday workflow. If you want to say, all right, I changed the output of this function and added this date that changes because it's the date, the receipt generation date, for instance, then of course every time that you are generating new receipt, then the content would be different. So again, the library says it's all up to you, developer, to make sure that whatever you're storing in these files is deterministic, so that when you're comparing a new version, anything that you find as difference are things that you might not expect. Now, to mitigate this kind of risk and make sure that this process is less noisy, the library, the approval test library, comes with certain helper features such as scrubbers that allow you to say, all right, I have this date that changes from time to time. I'm going to scrub that and redact that from whatever is stored in this file. But then, it's there in the, production environment. I would say that these scrubbers are very helpful for someone who is intent to using snapshot testing libraries, but at the same time, all those things that I discussed remain with snapshot testing as a practice in general. So this was a very simple kind of example that I showed you. I'm now going to jump back and say why we quickly abandoned the practice of snapshot testing. So, so when I go full screen, again, this screen freezes. So maybe what I would do is to just basically not go full screen. Would it help if I do this? Not really. Okay, it's all very clunky again. So let's stick with this one. It's easier. Okay, so here the frustration with all these kind of like testing systems that we had in place at Canon, for me as a software engineer, was so much that I started kind of creating a kind of side project and working on it at nights and weekends to kind of use a different approach to this practice. I said, well, what I don't like about snapshot testing is all these files that get generated and all the work that developers need to do in terms of comparing the files and inspecting all the differences. What if we could remove the need for generating these files altogether and kind of have a system in place that would automatically do the comparison for us, visualizes any kind of differences, and provides aggregate reports for developers to just take a look, see if it's to their liking or if it matches their expectations, if there are any differences. In most cases, when developers are writing code, they're changing functionality in a way that like basically shouldn't actually like surprise them. So anything that would be surprising then could be reported to the developers at the time that they are making code changes. The idea was not to like have this kind of separate system that runs maybe as part of the CI or somewhere after the development stage that gives you that feedback. The idea was, how do we make sure that we could do all of these kind of work automatically so that we could give the feedback in near real time. And the way that I kind of devised this kind of system was to, instead of creating files with the output, we would essentially capture any variable or runtime of any function that developers are interested in. We would let developers to say, if I have a receipt as an object, then I would just want to serialize that same object, however it is, or maybe define my own serializer and say, here is a representation of this value that is stored in this variable. So let me just track that. Instead of textualizing everything, we would serialize them in binary format, and then instead of restoring them somewhere, we would submit them to a kind of a separate system that takes care of all the comparison. And because these are binaries, then it could compare these in their original data type. So this method, of course, has its own drawbacks. It's kind of it's an overkill for very small projects, because then you have this separate remote server that has to run all the time, so that when you have a new version of your code that you're like just making code changes, you could submit to this server and trust that this server would compare it against your previous baseline. But at the same time, there is an advantage to having that remote server, because now all of your test data are stored in a central location. So therefore, not only the server could kind of do the comparison for you, it could also run higher level analysis on your the historical kind of evolution of your software workflows. It could say, oh, this particular workflow is now taking longer. Gradually, it's basically increasing in terms of runtime, for instance. So I only want to basically give you an idea by showing you some code snippets, but there is a demo at the end to show this in action. So in this case, let's just take a very simple example of, hey, I have this student object. In this case, I'm using record, which is introduced in Java 18. The idea, however, is just, you have some object that you call as output of your code under test. In this case, the student is, a representative of the profile information of a given student that we are searching in a database given their username. So the main entry point to our code under test is this find a student function that takes a username and provides this student object. The idea is if I could kind of remove all the expected values of my unit test, then and just say, all right, as I am, as software engineers are familiar with writing unit tests, you would say, oh, I am interested in this particular data member or like attribute of this object. Therefore, let me just basically check that. The check here is essentially happening in a function that is annotated with a tuka.workflow. And tuka, by the way, is the name of the system that I created. And the workflow, this annotation simply says, here is a function that takes different inputs, different test cases as its inputs. So therefore, every time that I have a test case, I would pass it to my workflow under test, in this case, the find a student function. And whenever I get a student, I basically start checking any kind of sort of information that is of interest to me, that I want to compare between across different versions of my code. So that's it. Essentially, you are creating one function, and because we don't have any kind of expected values that we are hard coding explicitly, then we could reuse the same description for all of these test cases that we have. Now, if you have 16,000 test cases, then of course we could just basically pass them one by one to this one function. Essentially, every function is going to be the workflow that we want to test. As long as the sequence of actions that we want to take to get to that output object, then we could reuse the same workflow for all our test cases. And because this was meant to kind of replace all of our frustrations with the old systems, I had certain design requirements in mind. One was, I don't want someone to say, all right, Pejman is no longer working here. So this was very specific to that project of replacing 500,000 lines of code. So therefore, we cannot use it for something else. I wanted it to be generic enough that would kind of cater to any kind of use case that developers might have, any sort of workflow. And then the other thing was I wanted this to be developer friendly because again, all these software test automations that we know are maintained and run by QA test team, and I feel like that's where there is a disconnect between developers and QA team. To lead to those long feedback cycles, I wanted to make it so that developers could just run their own tests and then rely on the system to run all of those tests automatically for them. So therefore, developer experience was very important. As you see here, I'm only saying, hey, I want, I'm passing different member variables to this check function, but I'm not specifying these their types. So the idea was if these variables have intrinsic data types that are known to Java, then the library should just handle them automatically without requiring kind of adding custom serializations as certain JSON serializers do. But of course, you can add your own serializer. In this case, if you wanted to just, instead of passing individual data members, you just wanted to pass a student, then you should be able to either just rely on the default behavior of the library or introduce your own serializer. And lastly, it was important for me to like basically remove the kind of the friction of having developers kind of have to do an extra step of inspection to understand whether a given set of differences that are found by the system are correct or not. Uh, the notion of creating high-level reports that developers could just take a look at and say, all right, this is this is fine, this is matching our expectation, was important to me. So that kind of external server that I mentioned, I created it with a UI, kind of web UI, so that developers could just say, all right, if we have a new version and we are debating whether to release it or not, we could just take a look at this page and say, if this last version that we've submitted matches, the behavior that we trust for a previous version of our code. So as you see here, this web page shows that kind of remote server interface. It shows how my software has evolved over time. By on the left side, you see all these different versions of a given workflow. In this case, that student workflow that I showed you. And the idea is you could basically compare. The server is doing the comparison of any new version against the baseline version, which is shown with a star. So as a developer, if I want to see what has changed in version 5, I could just basically click on this and inspect, my test cases. In this case, I see, hey, this test case Bob has differences, so I can click on it, and the server is showing me all the differences between version 5, which is the new version that I've submitted, and the baseline version 2. So if birth date, for instance, was a local date, then the Java SDK is essentially creating kind of this serialization that allows me to see different properties of that object. So I don't. I want to show you this, this workflow in action. So let's see that same workflow. This is my student class, and then I have this find a student function in my production as my production code. So for me to run this with this kind of new regression testing library, all I need to do is to just basically write a student test file and kind of annotate a function that I like to get that workflow. And then because the username, which is the test case in our case, is passed as a parameter, all I need to do is say, I'm going to pass this username as is to my find a student object. Whenever I get a student, here are the things that I want to track. So in this case, then I could simply just go check the API key and API URL, add them as environment variables or as command line arguments, or add them in some configuration file that the library provides, so that every time I have new code changes, all I need to do is to just basically specify the version here. So I'm specifying the test cases, but I can even remove them and let the library actually query the set of test cases from the server. So I'm explicitly specifying them here to see, for you to see that I'm passing Alice, Bob, and Charlie as test cases to this workflow. And in this case, the library would essentially run all of these test cases, and then every time it gets an output. By the way, the screen froze again, so you don't see. Oh yeah, so it's fixed now. Every time it tracks all these values and runtime of functions, it just submits all that information to the remote test server. So that's it. I basically submitted a new version 6 to the server. So if I go back, I see that the server has automatically compared it against the baseline version. So if I click on it, I see all the differences. For instance, in this case, everything has changed. So we can take a look. Oh, for instance, birth date no longer exists, or it's serialized in a different fashion. So it's up to us as developers to see if these are fine or not. And in this case, I'm going to say, for some reason, I trust this version of my code, so I'm going to promote this to be the new baseline of my software workflow. So I'm going to promote it with one click. and then trust that from now on the server would compare the behavior of my code against this version. So let's just submit another version. This time, let's remove all these test cases and submit version 7. And as you see, like the SDK just queried the server for the list of test cases to use, which is very handy when you have lots of test cases, maybe thousands of test cases. But the idea here is that now if I go back, I expect, because I didn't make any code changes between version 7 and 6, I expect everything to be the same. In this case, the right side shows the differences in performance, how my software has evolved over time in terms of runtime. This is actually, you could not only just track the runtime of your entire workflow, but you could also say, if I have like a particular function that I'm interested in, I would add the runtime of that function as a metric. And then the server would start comparing these together. All right, I only just wanted to give you a sneak peek of what the server does and how it works. The idea, however, is as a software engineer, I no longer need to do anything for getting the comparison. And as you see, like I had to go to this web interface and all that. That's totally optional. The server automatically kind of sends you an email or a Slack notification to let you know if you have kind of any differences, and then it submits that high-level report for you to kind of understand if you actually need to go check the details of the differences in this web page and web platform. All right, so that was the demo. I just want to say this is I'm sorry for all the frozen screen and all that. I hope that at least I was able to to give you some ideas of how these regression testing systems work. The idea for this kind of system and workflow is that you don't want to run them kind of in simply just basically once in a every few weeks when you're close to kind of releasing your version. You want this to happen just as regularly as you're running your unit test. In this case, most of our users are kind of integrating kind of these libraries with their CI workflow. So that they get kind of this insight automatically delivered to them as they are kind of pushing changes to a given branch. Because you could trigger these workflows as part of your CI, or maybe register a webhook to run them in a separate test machine, then the idea is you don't have to wait for someone else to do anything. Just get this feedback immediately as you're writing code. So yeah, so here Ivan is asking a silly question, why Tuka? Well, I just wanted to come up with a name that is very short, so that if as a developer you're using basically the Tuka command line and you just want to run all these tests with the CLI, instead of running Gradle or anything else in other languages, you would just be able to type 5 characters. That was pretty much it. There is no meaning associated to Tuka anyway. So yeah, naming is hard. So any other questions?
Yeah, we'll just give people a minute or so if they're typing furiously their questions now.
Absolutely, let's do that.
One question I have is, I know you mentioned Spock earlier.
Yes.
Does Tuka work with Spock?
Not yet, no. It's only basically working with the JUnit platform right now and version 5. So that's kind of a limitation, but at the same time, if you, I don't know if I've managed to I didn't mention this, but what I actually did here was I cheated a little bit by running instead of Gradle test, I was running run example main, which is like a Gradle task defined that would call this, separate executable. In this case, you see that I have a static void main function here. The idea is if you use the same set of examples that I was using here for like testing, our integration for different things and all that. So, but yeah, we do support JUnit 5 right now. Hopefully, if there is demand for other test frameworks, we'd love to have other integrations.
Okay.
Yeah. So Ivan says in Portuguese, tuca means cap. That's correct. Yeah, I wasn't aware of that, by the way. So I should have done more research to so that like when people kind of search tuca on the internet, they don't see a bunch of caps that they can buy. But that's the reality. Naming is very hard, especially like if you are looking for 5-letter like words to like register a domain or whatever. It's just a nightmare to find any kind of word that is easy to pronounce. Yeah. So Kurt is asking, what about versioning cross forks in an OSS world? Oh yeah. So if I understand correctly, let's just say I have an open source library. Kurt would kind of fork it. They add their own kind of make their own changes to it, and then they submit a pull request. Or maybe not. Maybe they just they're in the middle of making changes and want to make sure that it works correctly. So in this case, what we've done is we've enabled kind of teams, in this case, to clone a particular workflow. So in this case, you see here that like I had a workflow called student. Now, if I am working as a team, I might have multiple workflows for different kind of workflows of my software. Maybe one is data ingestion, another is visualization, and any kind of library that you want to test and kind of integration test you want to create would belong to a separate workflow. So it's very common for teams to like basically use certain like work in separate branches, and they don't necessarily want to like deliver code to the main branch to see them everywhere. So what we've done is we've allowed teams to actually just say, all right, I want to clone this student. Maybe they would name it something else. So in this case, if you are forking this and creating your own, you need to be part of my team, by the way, to say, all right, I'm cloning this. I would name my own workflow as students underscore, for instance, Kurt. And then when you are making changes, because you're cloning, you have access to the baseline version as well as all the previous versions of this workflow. In this case, we are not duplicating content. We are just creating references to the other workflow so that like we can basically run the comparison in your separately from the main workflow that the maintainer of that OSS library or any kind of other repo might have. And by the way, so the cloning is you could do it in the settings right now, but the cloning is kind of, it requires that you are part of this team. And the idea is because all of these test cases and test results are submitted in one central location, then you want to have all of your team be able to go, access this web page and see all the results. So in this case, I am the only person in my team, so there is no like button that allows me to fork this workflow. But then I can, add anyone in this case to be part of my team, so that I could not only share my, code, but also like, do certain collaborations. For instance, you could write comments for every version, or when you are promoting a particular, in this case, if you are promoting or demoting a particular version, you could actually write comments to let your teammate know why you're doing this. So yeah, that's how it works essentially. You need a separate kind of a view of all the test results to make all these test results yours, so that you could do your comparison without disrupting someone else. Yeah, kind of a long answer, but I hope that I gave you the idea. Any other questions?
I guess while we're waiting for other questions that might come in, somebody earlier asked if the slides will be available.
Oh, absolutely. Especially now that the screen was frozen and all that. I definitely sent the slides to Mike. I know this is completely irrelevant, but I found this kind of open source project called SlideDev. And I'd love to just basically touch on that because I'm in love with this project. It allows you to write your slides in Markdown, and then it basically serves those Markdown in form of the slides. So what I did for my slides is I just wrote a simple Markdown. I think it's less than 200 lines, all of those slides that you saw. And I got this. So yeah, I definitely recommend that everyone checks this out. It's especially if you're presenting for someone, or like basically want to do more than just showing some text on a screen. You want to maybe include a video or a tweet. Then this is definitely worth checking out. It's a complete kind of view app.
Okay, and I think our issue was with StreamYard, not with SlideDev tonight. So
yes, that's right. Yeah. Well, again,
SlideDev.
I'm sorry that happened, but yeah. So Ivan asked, is this similar to the concept of mutation test? Sort of, yeah. I guess there are certain words that like you couldn't necessarily like isolate them. So for instance, there are like concepts like property testing. You could say that this is sort of similar to property testing. The way that I understand it, mutation testing is or sometimes like characterization testing and all that, is the idea, it refers to the idea of, hey, you're basically checking how your software is evolving from one previous version. In that case, any kind of a snapshot testing or regression testing could be considered mutation testing. But the method and the kind of the tooling around how to provide that feedback obviously differs from all these like different tools. So I think the best the best kind of word for this is just regression testing. At least that's what you're using, just because regression is a concept known to like software engineers. They use it day to day, and the whole idea for this kind of method is for you to see if you're causing regressions or not. So I think it's very relevant. Approval testing, on the other hand, has chosen the name approval testing because they want to emphasize on the practice of approving a certain behavior, which I really like. So that's another like interesting perspective. You're essentially like emphasizing that this requires approval by the software engineer. But yeah, it's all very different terms for the same concept, I guess. Yeah, well, okay, if there are no more questions, and please feel free to ask more, but I just wanted to thank you again. Sorry for all the technical glitches, but I hope that this was worthwhile for you. And yeah, you can always find me on Twitter. I'm active there, as well as the code that I showed you and the software that I showed you are available here. Just want to, because I demoed approval testing too, I just want to like show you this too. The screen doesn't do justice here, so let me see if I can move it here. Yeah, so it's called approvaltest.java. Yeah, thanks everyone.
So like we said earlier, we'll make sure that these slides get up on the Meetup site. And of course, you can always rewatch this video on our YouTube channel. And I'll just remind everybody to look out for an email from DJug about a survey that you can fill out if you want to meet in person again soon. So hopefully that can happen. And thanks for coming tonight. And we'll see you at our next meeting, maybe in person. All right. Good night, everyone.
Thank you. Have a great night. Bye. Thank you, Mike.